Now we have a very interesting keynote speech on the topic, the token economy, presented by Dr. Kasun De Souza. Dr. Kasun obtained his undergraduate degree from University of Colombo and PhD from Stockholm University. His research areas are information security and embedded systems, and he works currently as a senior lecturer in the University of Colombo School of Computing. So we'd very warmly invite Dr. Kasun De Souza for the keynote speech.
Okay, good evening, everybody. Thank you very much for staying too late in the Friday evening to hear my talk. Basically, as you may see, I'm going to talk on token economy, kind of a decentralized web. In order to come to the important point, before that I will roughly go through these new technologies, cryptocurrency, blockchain, smart contracts, and what are they, and so on. Because nowadays people are talking about those things as buzzwords, and some people have no idea about what it is, whether we can apply it or not, and so on. My name is Kasun De Souza. I think most of you know me. I'm very glad to be delivering this keynote because actually 20 years ago, in 1998, this ICTer conference was started. I was at the audience like student, and then I talked to one of the keynote speakers, Professor Sead Muftik, and eventually after 3 months I ended up with Stockholm. I think Dr. Ruan also here. Since thanks to the Dr. Ruan and the teams, I started my PhD in somewhere in 1999 in Stockholm, Sweden. So that's how I started my career in information security. So I'm glad to be here in the same conference, delivering this keynote in the latest technologies, basically on those days in the area of security. Right. Let's talk on cryptocurrency and what they are and how it works and so on. I think some of you know about it, but in order to take audience to the same level, let's discuss what cryptocurrency first. There is a difference between cryptocurrency and digital money or the digital currency. So the cryptocurrency started first with the digital currency somewhere in 1998. When I was starting my PhD, I was also working with some electronic currency systems. So in that era, electronic currency always linked to the physical real currencies. So it's electronic versions of real currency. But the cryptocurrency is not so. Cryptocurrency is completely different. The person who invented first electronic currency system, together with a concept called blind signature, called David Chaum, in 1990, he published his first paper on blind signatures. So he said that, like, if you want to get real democracy in the world, we need to have kind of democratic currency systems, which we need to get rid of. In other words, we need to get rid of central banks and governments, and need to have currencies which controlled by people. So the cryptocurrency is actually the currency which controlled by people. So among those cryptocurrencies, the Bitcoin is, famous, and everybody perhaps heard about those Bitcoins. Bitcoin is one of the best kind of a high-valued cryptocurrency right now. In addition to Bitcoin, there are so many cryptocurrencies in the world. So there are other versions of cryptocurrency. We call it as crypto tokens. I will let you know the difference between these protocol tokens, or what you call Bitcoins, and cryptocurrencies and other tokens. People usually consider both as kind of currencies or electronic tokens, which has some financial values. Bitcoin started as a first such cryptocurrency system somewhere around 2008 by an unknown person called Nakamoto. Maybe he's a person or maybe he's an organization. We never know about him. And he started that scheme, and somewhere around 2009 to 11, it has very slow start. Nobody care about it. But some computer underworld guy, bad guy, who invented the Silk Road underworld website, which delivered guns and drugs, accepted his payments using bitcoins in 2011-2013 period. If that started with that Silk Road, the Bitcoin got a lot of attention in the world. And after that, a lot of virus, ransomware, start using the cryptocurrency to collect ransoms. Especially Bitcoins, they used to collect ransoms. So with that, somewhere 2013 to 14, 15 period, the price of Bitcoin was skyrocketed. Like it went to Bitcoin was released equal to $1. One Bitcoin is equal to $1. And in somewhere in 2016, 17, it was $20,000. One Bitcoin was $20,000. However, now it dropped down somewhere around now $6,000. One Bitcoin is. What Bitcoin do? Bitcoin, it's an entire protocol, network protocol, is peer-to-peer protocol, which kind of go in between, exchange the currencies, actually kind of digital assets between the people. This protocol itself take care of the creation of these assets, and it take care of how do we secure transfer those money from one person to the other person. And it provide pseudo-anonymity. That means if you create address of the Bitcoin without revealing your name, it's anonymous. Some people create address for each and every transaction as well. And it has a nice concept called blockchain to stop double spending. Because if you have an electronic version of currency, so we have a problem, what we call it as double spending. That means if you pay that currency to someone else, and he can pay the same currency to other person as well. So we need to stop transferring same amount or same currency to two person. We need to stop that. So in order to do that, so the protocol itself invented a new technology called blockchain. So the Bitcoin, the main invention behind the Bitcoin, I feel it's a blockchain. It's a very simple technology, but solves a lot of security problems, especially a problem called immutability. I will come later on. So I'm not going to discuss about detail about Bitcoin protocols, how it works, and how can we program it, and so on. So there are workshops in tomorrow which I do that. In principally, how this money created in the Bitcoin. So even we say coins, actually it's not kind of you can touch and see. It's not an entry in kind of your account name. It's actually entry. It's in a distributed ledger. It's a ledger entry which says that person transfer this amount to the other. So then anyone can transfer any amounts. So then anyone can write a message to anyone saying, I give this much to the other. So if you try to do so, there are no value for that entry. So we need to have some methods which basically controls that. So basically where we create the money in the place where what we call it as mining. Mining means basically creating immutable data blocks of transactions. Those blocks has a special algorithms, and we have to create that blocks in such a way, so if some person create a block, he get a reward. So this reward create a money. So the protocol difficulties kind of define, it's kind of increasing with the time because power of computer get increased. So we need to increase the difficulty of protocol, otherwise someone will create the money all the time, at a short period of time. Right now there are big companies involved on creating those blocks. When they create a block, they get a reward. So reward is some fixed amount of Bitcoin. So there is based on those algorithms, there is some maximum number of coins can be generated forever, and these coins then start transferring in between each other. In order to transfer those monies in between people, we need to have some kind of identity. We need to create identity. So in order to use any kind of cryptocurrency, so the holder of the currency need to have an address. So that's called as a cryptocurrency address, or in the Bitcoin it's called Bitcoin address. So Bitcoin address created in the cryptographically, they use public key cryptography, mainly elliptic curve cryptography. So they use they create public-private key of elliptic key cryptography algorithm and take a hash of this private key and then do base 64 encoding and take that as address. So address is a hash of their private key. It's used as address. So if we want to transfer money, we send a message to a network saying I am transferring this much to the other person. If I am X, I say I am transferring one currency, one coin to Y, digitally signed by my private key, and send the public key also to the network. So everybody in the network see that message, and they can verify whether that is coming from this private address. They don't know the person, but they link into this private key, what we call it the address of the Bitcoin. So in order to use these coins or any cryptocurrency, we need to have cryptocurrency wallets, right? There are online wallets, offline wallets, and so on. So there you can create accounts and create those key pairs and then generate money, buy money, transfer money, and so on. These days, there are so many such online currency wallets. So when you write such transaction to the network should store that somewhere in the databases or whatever. As you may know now, kind of in the last keynote, so our Dr. Kevin mentioned that the relational database is kind of a legacy system. So in this Bitcoins, they are not using any relational databases. Instead of, they use a new storage, what they call it as blockchain, blocks. Blocks consist of transactions, kind of list of transactions. So as I mentioned, people in the world transfer their all transaction to everybody. So everybody has a copy of it. So at the beginning, each end users keep those copies. Nowadays, it's not possible because size of this all transaction ledger is over 175 GB right now. So nobody can keep entire ledger at their places. So now most of the miners, people who create the block, keep those copies of transaction of everyone. So usually what people do, people transfer their money. So all miners get those copies, keep into their pending transaction list, and they took those pending transaction list and create a hash of those transactions according to the Merkle tree structure. So for example, they take the transactions and create hash of it, and combine all hash, create the hash of it, and hash of it, and hash of it, and create some hash. So then they take the hash of such previous block and this hash of the existing pending transaction. How do they pick it? Based on their algorithms and the current time and some other detail, and they have to find some nonce, random number, which create a hash based on this Bitcoin mining algorithm. Usually this algorithm says these miners need to find the hash starting with some leading zeros. So until they find a hash starting with leading zeros, they chain this nonce. They kind of randomly or based on the algorithm, they have to generate the nonce and check whether they get a hash which match that condition. if they get a hash which matches that condition, they announce it to the world saying, I found this number which satisfies this transaction, and in other words, they say they found a block, create a block. If some miner found that number, he gets rewarded a set of coins. So that's actually kind of self-transaction. It's called coin-based transaction. So miner, one of his transaction in the miner, it's actually right to himself, saying, maybe this transaction 3C, saying, I own 12 point. Right nowadays, if mining is 12.5 Bitcoin, someone can get 12.5 Bitcoin by creating a block, as I remember right now. So then this one, it says, it's a kind of transaction itself. So miner says, I own 12.5 Bitcoin because I found this number. So it also included this block. So when this process created, so whoever Nakamoto created the first block, it's called a genius block. It has a money entry saying he owned this much of Bitcoin, kind of. So he mines itself, and then he put, okay, since I mine it, I want 25 Bitcoin. At that time it was 50 or 25, I couldn't remember, like that. So it's entries, kind of just entries saying money goes from here to there. So then if someone creates a block, he has to take the hash of this block, include it to that, and set of the existing pending transaction, put it there, and find a number. If they find a number, they get 12.5 Bitcoin right now. So that's how these coins created. So that's how Bitcoin created. So similarly, there are so many other cryptocurrencies. They have different mining methods and different other ways of creating crypto tokens as well. I'll discuss in a minute. Usually what miners do, they take entire transaction in the world and kind of create a hash value and verify the signature of all transactions, and then try to find these nonce and then create this particular block. Finding this nonce is kind of very hard job, so it takes time. So if someone wants to cheat this chain and alter transaction, kind of transaction here, somewhere down the line, they have to all change entire blockchain to that. That's not possible because it takes so many processing power. In other thing, miners don't need to try that because instead of that, he can create a block and get 12.5 Bitcoin. He don't need to try to change these blocks. Right. So I think you have a kind of a rough idea what now blockchain is. So in general, blockchain is kind of a data storage, distributed data storage ledger, which store transactions, entries securely. So main property of this chain is immutable property. It's an immutable property. That means it's very hard to change. If somebody try to change, it takes time. And it's kind of impossible to change. So if there is an entry in that, we cannot edit it. No edit function in this chain. So if someone wants to alter, they have to append the record. So that's how blockchain works. So they are chain of kind of data structure. It's a write-only database, kind of write and read-only database. Kind of cannot delete, append to the records. So this structure was used only for payments, financial payments. So when people realize this structure and its a security, researchers thought, why not we apply for different other purposes? Because there are so many day-to-day applications which need this structure, immutable structures. So for example, deeds, so vehicle transfers. So we need that. So should not be able to alter the previous records. Maybe banking, manufacturing, food chains, food supply chains, audit trails. So if someone alter the audit trails, then there are no security. So we should have the chain of that, like blockchain, so then nobody will be able to alter. So then it's suitable for maybe audit, maybe food distribution, manufacturing, banking, like that. So beauty of cryptocurrency is rely on this blockchain, or the simple idea of blockchain. However, it works in a very complicated way. So, but with that, we could find very huge variety of applications. So, starting from financial, there are blockchain first application is financial application, that is Bitcoin anyway. So, among these applications, what I focus today is this, smart contracts. So, it's another innovative kind of application where we could use to do so many various things. So, I personally believe in next couple of years, so the world may change based on those. New technologies emerge because of this smart contracts. What is smart contracts? Smart contracts are a piece of code, program, where stored on the chain. So not only financial transaction, same blockchains can be used to store the codes, programs, right? So then all the people who has that can execute those programs. Executing means change the state of the code. So it's like a huge computer. So Bitcoin blockchain does not support it. So if you want to do storing the transaction, Ethereum is kind of famous blockchain right now available in the world. Ethereum infrastructure. Ethereum is another cryptocurrency similar to Bitcoin. So they support not only the financial transaction, but also executing the codes. So then those codes, or what we call contracts, everybody will see that. So everybody can execute. So everybody should get the same result. So no one will be able to alter this code. And since everybody sees the results of this execution, it has open contract. In other words, Ethereum is a huge computer where people can put the code and let that computer to execute. So if we create such infrastructure, everybody can put the code and executes. So someone will write a for loop, or someone will write a code which exhausts entire resource of this infrastructure. So they have to stop that. In order to stop that, they have introduced financial value for execution. In this infrastructure, if you want to execute a code, so there is a value associated with all opcodes or execution of these instructions. So people who request to execute some function on this huge Ethereum machine, so they have to pay for the execution. So that they call it as a gas. How would they pay? They would pay using a cryptocurrency called Ethereum or ETH. So if anyone want to put some contract, what we call smart contract or code onto this network, they must have Ethereum. So then they have to pay the execution using Ethereum. So then there is a kind of a financial cost associated with the execution. When you want to see transactions on the Ethereum chain, you can go on this etherscan.io website. There you may see all the statistics, how much this Ethereum costs right now, how many transactions goes right now in the world, and so on. So people start actually using it. So in order to write these codes, Ethereum invented different programming language called Solidity. So it's similar to JavaScript. So it's a new kind of programming language created to write codes to this big computer, or called Ethereum virtual machine, which is distributed all over the world. So then people can write the codes using Ethereum, Solidity, and then put it to the Ethereum virtual machine, pay by ETH or the gas, and then do the task. So not only that, there are so many other blockchain technologies or the networks available which support smart contract. One is the Hyperledger from IBM. IBM has a product called Hyperledger. So that support different programming language to write those contracts. Ethereum, if you want to do Ethereum network, you want to use Ethereum network, you have to write it in Solidity. Similarly, in UCSC, we have created our own blockchain for private. There are two kind of blockchains, like private use and kind of public. Bitcoin, Ethereum are public chains. Anyone can use it. Maybe within the organizations, they can use their own chains. So we have created such chain called MysticoDB, where basically can store the transactions in similar way and mine it and so on. So there we also support smart contracts. We selected Scala as programming language because it's functional. So we guess the functional may nicely fit that. We never know, we're still in the initial stage. But our blockchain is in the commercial production level. So it's used by Sampath Bank right now with this particular application, the iGift. You can download and use on the Apple Store and kind of Google Store. This application don't use relational databases to store their transactions. So they use our blockchain infrastructure to store the transaction. So it's practically commercially used. Right. So then applications. So applications which runs on top of such chains, we call it as distributed applications. Sorry, decentralized application, or in the short name called as dApps. So I personally believe maybe world may move into these dApps. So how the traditional web system works? In the traditional web system, you know, we have a server. In behind, we might have a database server, and we have internet. So those clients will connect to those servers, most time web servers, and then get the pages and execute web applications, right? And then backend to the databases. So that is traditional webs, Web 2.0. Now it's kind of going to obsolete. So we are now entering into an age called decentralized internet. In the decentralized internet, we are calling to not to the central applications like web applications, web backends. We call to the contracts, smart contracts, or the codes which store on the chain. So our business logic or the codes basically stored on a blockchain. It may be Ethereum or maybe another chain. And any nodes which host it can basically verify. And how do they distribute those? It's a peer-to-peer network like BitTorrent early days. And the data is in the decentralized storage. We don't need the centralized equipment like DNS servers, web servers, and so on. So because of that, such decentralized internet denial of service attack is not possible, because data itself plus application itself is decentralized and distributed. So without confusing you, so I just want to mention these three names. We have centralized web and we have a distributed environment like that. So in the future, internet is kind of decentralized and distributed paths, both. It's a decentralized, not depend on the central servers like DNS servers and web servers and so on. So there we have what we call it as dApps, distributed applications, which talk to, maybe through web browsers, same web browser or maybe a different browser, talk to a virtual machines or blockchain, or what you call Ethereum. In this Ethereum case, Ethereum virtual machine may be a different huge virtual machine decentralized all over the world. So same app, every app may have a different entry point. So whichever the entry point, they talk to the business logic stored on those chains. So those business logic or the code, we call it as smart contracts. Right? So those smart contracts, we call the function of the contracts, so then they execute and produce the results back to those apps. So they call it as distributed apps or DApps. People call them Web 3, Web 3.0. So there are APIs developed right now, and libraries are available to build these DApps. Using such contracts, for example, we can do a lot of things. So for example, we can even create a bank. What bank do? Bank usually have deposit function, withdraw function, balance checking functions, right? So without having any core banking system or relational database, we can write a solidity contract like that, which basically deposit money, this will withdraw money, and this check the balance of the money. So everybody who has used Bitcoin addresses can store the money by calling those functions in the contract. So then the status or your records are decentralized and distributed all over the world. So then, of course, everybody will see that, but nobody will be able to alter it. We don't need to have expensive core banking systems. So it's a kind of virtual bank. But what have we stored there is kind of virtual money. So in order to execute that, we need virtual money, or what we call cryptocurrencies or crypto tokens. Today we can see three types of decentralized apps. One category is Bitcoin, financial apps. So Bitcoin, Ethereum, Monero coin, so many coins are there, so coin types. So they are basically type 1 application, distributed application or dApps. In the type 2 dApps are kind of applications where people create instead of loyalty program. So for example, you can create an app in the Ethereum blockchain, for example, saying with some cryptographic tokens. At the beginning you say you create the app with 1,000 tokens, on maybe from 1,000, 80 tokens owned by you, and you ask other people to buy the rest of the token by exchanging the other cryptocurrencies. So then people may buy it and then try to exchange that. So I'll come to that later on. So basically, such loyalty kind of tokens, applications are the second types. And the third type are kind of new way of application, completely new application, new methods, maybe which require transaction properties like insurance applications where a lot of people get interact, and then people can interact with, and the claims will go to each other using crypto tokens. So all those DApps works with the crypto tokens, cryptographic currencies. They are not going to use physical currencies. So some examples are there. Some of them are actually not succeeded as we expected, but as you know, so when the internet started with .com boom or .com bubble in somewhere in 90s, so many .com companies, but most of them failed. But few was survived, eBay, Alibaba, Amazon, and they become multi-billion companies. Similarly, now we are in this blockchain or smart contract bubble. So many applications, but I personally believe 90% of them definitely going to be failed, but there are few will survive in the future, and they create the next generation of the internet. One such application people talk about is GLOM, Gulen or something like Gulen. So that's a distributed open source supercomputer. So there you can upload your task, kind of rendering task, data mining task to that. And that will process those tasks and return your result. So who is contributing to that? Yourself. Your computer power you can contribute to this goal-on network. So then the tasks will distributed over your computer. Some parts will execute on your computer. And for that you get a payment. How do you get the payment? You get the payment from these goal-on tokens. So they have their own tokens. So people who wants to execute the task have to pay with this token, and then people who donate in the power earn by getting these tokens. So if then automatically with some time this token get a value. It create kind of an economy there. So then there is a limited number of tokens issued at the beginning by Golan. So then who use this entire community has to use this token. If the demand goes high to this Golan supercomputer, the value of this token going to be high. So I will show you the value right now, later on. So that's how it works. So as you may see, Golan-like DApps use their own tokens. They are just tokens, kind of loyalty points, not such cryptocurrencies. But those tokens also considered as some kind of cryptocurrencies because they have financial values associated with that. So when the inventors or the writer of those apps, when they release those apps, they create a fixed number of tokens. And they keep some of them within the developers and ask the inventors to invest by the rest of the tokens. So then investors in the world can buy those tokens. So that we call it as ICO, or initial coin offering, ICOs. So using the ICOs, app developers, DApp developers can earn the money at the beginning of the development. So for example, in the traditional app developers, after they develop the app, there is a bootstrap time. So until any considerable amount of users start using an app, they don't get any financial benefits. So if the people start using the app, of course they get benefit. But with ICOs, they can link it to the financial value at the beginning. If their idea is smart and investors like that, investors will invest by purchasing their tokens at the very beginning. By investors hope in the future, those apps get high demand and then this value of the token will go high. So then developers of apps, DApps, will kind of earn money at the very beginning, and if the users going to be, number of users who use those dApps going to be high, the demand will be high, and their tokens get high values. So then, with the time, they can earn a lot. Investors plus the developers. So because of that, developers like this model. Some people have created virtual businesses out of this model. So such businesses call it as decentralized autonomous organizations, DAOs. So in such organizations, there are no legal contracts, no staff works. So everything virtual. Company is a piece of code which runs on the Ethereum network or some other network. And that has some initial tokens, and investors purchase those tokens, and then that's their company. Their code tells about how to distribute the shares, how to distribute kind of profit, how to take the decisions, and how to vote it, and so on, entirely through the code. So then people believe we don't need business lawyers in the future if such companies start existing. One such company created very beginning is called the DAO, Decentralized Autonomous Organization. And when they offer this, their initial offering, these tokens, through the initial offering, they have collected 11.1 million of Ethereums. That's kind of billion of dollars worth. And kind of 18,000 stakeholders all over the world purchase those tokens. That is actually fundraising mechanism. And number of employees are 0 in this organization. No employees. And it's a contract on the Ethereum network. And this token has a value. And then applications basically call these tokens. One such other application is called Uber. Not Uber, it's Uber. It's a decentralized prediction system, betting system. So people can bet for some things, maybe for election, maybe some weather conditions, or whatever. And they bet using this Uber token, and Uber tokens has a value, and they can bet it. If they win it, automatically the things will transfer to their account. So that everything is automatic, transparent, everybody will see entries, and everybody will see what happens, and so on. So basically, that's created a different business model. So such new business model, we call it as token economies. So if I summarize, so basically we are in these centralized economies, web economies, where we have applications like Facebook, Google, Twitter. They are like data monarchies, right? So they own our data and they own our money, right? They are not going to share it with us. We use the system, they provide it free of charge, what they say, forever. But actually we are paying, not using real money, we are using digital assets. We pay them using digital assets, so that is our data, right? So now it's going to change. So that's what I personally feel, and I would like to work to change that as well. So in this traditional internet, where these big companies, only these big companies own money, need to be changed. So the way we need to be changed is this decentralized web. So as you may see in the traditional webs, so we have hosting application, Amazon or whatever, which process our business logic, kind of server-side applications, what we call, and we store the data in the databases, virtually stored, maybe in the Google Drive or Amazon S3, or maybe MySQL or any other relational database. We store the data, and these cloud service providers process them, and these big companies earn, we provide data. So that's the traditional centralized web. And now we in this age, the partially decentralized situation. So there we have dApps, some of them are kind of converted to dApps. And still we have processing, but now we have payments integrated to the blockchain. And some data now started right into the chain instead of this. So if you write this S3 or cloud or whatever data storage, of course we have to purchase those data storage or paid for these cloud service providers. If you store this in a chain, so it's globally owned by people, and it's not free actually, we have to pay. We have to pay by the tokens owned by us, ourselves, right? So in the future, we will move to that. This central processing will eliminated. Instead of, we have huge central computers. One such we have right now is Ethereum processing network. So we write the code and store in Ethereum as smart contracts. So maybe instead of Ethereum, there might be different economics comes up with different chains, right? So they might have different cryptocurrencies. So if you want to use such and store your code to there, you have to purchase those currencies, right? So those currencies owned by you, nobody control. You own it, you keep it, it's your currencies. It's your economics, right? Data or transactions stored in the distributed ledgers, or what we call it as blockchains, right? So most of the blockchains are not supporting huge data storage, like videos, whatever, huge films, and the large data could not be stored on the chain because of their data structure. So for that, there is now new technologies coming up. One such very interesting technology called IPFX file system, interplanetary file system, IPFX. So a lot of attention in the world right now on this IPFX. So it's a kind of similar protocol used by BitTorrent. So there we can store our files distributedly everywhere on the people's machine. People's machine, they talk through the protocol. So then people keep the data, people process it, and they are paying each other using their own tokens, not using dollars or rupees. So that we create this, what we call it as token economy, and with DApps. So we already have such tokens. As you know, Bitcoin, Ethereum, SRP, there are so many tokens, like over 2,000 tokens, crypto tokens, which has money. So you can buy and sell, and you can even generate. So for example, right now, this is the worth of Bitcoins in the world right now, trillions, I guess. One Bitcoin is, how much? This trading is 6,000, right? $6,000. And then Ethereum is 220. So kind of that's drop actually. This is also a drop. It was like $400. Now it's kind of drop. So as I mentioned, we were at the kind of this DApps boom or beginning bubble, and now it's kind of going to saturate. So in addition to that, you see there are some tokens called Uga, Gulam, Holo. So they are not currencies, they are tokens issued by distributed apps or dApps. So those tokens has also some values. So one Uga token worth $13. So one Gulam token worth this much. So if you want to use this processor, you have to buy this token on the cryptocurrency marketplaces. So there are cryptocurrency marketplaces. One is called Coinbase, and there are so many marketplaces I could remember. So using those marketplaces, you can exchange those cryptocurrencies to other cryptocurrencies or to the real currencies. So when you go into such virtual currencies, kind of cryptocurrencies, crypto tokens, and kind of token economies instead of this rupee dollar economies, what might going to happen? What are the pros and cons? So usually in the regular economies, rupees or dollars, they are, these tokens. So what are the pros and cons? Let's say what are the pros and cons of this such token economies? Pros, they are independent. No one can froze, people own it, no sanctions. So when people want to use it, like pay, receive, transaction, they have very less transaction fee. We don't need to purchase very expensive payment gateways. No, we don't need credit card. We don't need to pay credit card transaction fees, nothing. So small transaction fees, people can exchange, right? So usually credit card get 3% transactions, so many interest and so on. That's nothing, nothing be there. So only few transaction fee we have to pay for miners. So that's it. And they are secure. We don't need to have firewalls or whatever core banking systems, other security systems. It's run open network, peer-to-peer networks. So the running cost is very less. So because of that, it's secure, running cost is less, transaction fees, because of that, transaction fee is less. So how many transactions we can use, how amount, unlimited. Any amount you can use, billions, trillions, whatever. And it's like money, it's anonymous. So, or pseudo-anonymous. So it's like when you pay by cash, no one will be able to trace you. When you pay by credit card, people will be able to trace you. But if you pay by cryptocurrency, no one will be able to trace who you are, what you buy. And the other side, still these token economies are unstable. We never know what might happen. But so as I mentioned, few of those economies definitely survive. And still these volatile marketplaces, because few months ago, one Bitcoin is $20,000, but now it's $6,000. But its volatility is very good situation for investors. So investors like that, because they can earn a lot by purchasing money, plus by selling those tokens, selling those money. Still, it's not widely accepted, because governments and the banks, especially central banks, they get really upset on those situations. So they are trying to control now. They are trying to control those. But people start accepting it. Most of those people are bad guys. Honestly speaking, they are bad guys. So people ask for ransom, drugs, selling other bad things, they do through the cryptocurrencies, because they can very easily trade it without going through these government infrastructures. In other words, without catching the police or CID or whatever, because no way to trace. And when you pay that, it's kind of paid, no way to reverse it as well. And similarly, if someone hack into the crypto wallet and steal your private key, all of your currency has gone. Because it's like drop your wallet on the street with 100 million rupees. If your currency is associated to your key, and if your computer crash and you lost the private key, you lost the money forever. So these are the disadvantages, kind of. So let's compare those token economies with dollars, right? The dollars, backed by the governments, controlled by the governments, right? Politicians. But the tokens, backed by the users and controlled by the users. So the amount decided by the users, not by the politicians or the governments, how much you pay. And the value is decided by us, ourselves. So power with the people, not with the government or politicians. So when you think about like dollars, it's US is controlling. So as now the rupee is going up, US is controlling dollars, what they say. But this is international. So no government can control. So if the demand goes up, value will go up. If the demand less, its value will go loss. These economies. And this is created by government. This is created by the work or the tokens, applications, and so on. So this is unlimited supply in the regular dollars and other currencies, but this is limited supply. In the cryptocurrencies, always limited supply. There are no unlimited supplies. Hard to steal by hackers because it's physical, and then easy to steal by hackers because it's stored on your computers. So how do they hack it? At the storage, not in the chains. Not in the chains. Usually when the storage, your wallets, it's vulnerable because wallets are stored in your computers. So people maybe can steal your address and then they can get your money. So with these tokens, very easy to transmit because in a minute you can transmit one address to the other address immediately. So it should not take years or it not get through the payment gateways, no commissions at the end, just transfer. And main criticism on the tokens are from the government, they say it's used for crimes. Those crypto tokens, all the governments say they use for crimes, so we have to ban it. We have to control it. So I don't agree because dollars can be also used for crimes, right? So why we are telling only this? This can also be used for crimes. So then there is no argument behind that. So there are so many applications, DApps, and there are economies in the virtually present in the internet right now. So if you have a time, you can have a look on those. And especially I ask you to have a look on this. This is kind of getting very popular in the research communities. And this one, linked with the Ethereum, may create a new economics recently, in very recent times. So at the end, as a final word, I say crypto economies, I repeat it actually, I already mentioned, says for bad guys, cryptocurrencies for not only for, it's for bad guys. So that's the main criticism. So that's, because of that, we say it should not use. Actually, cryptocurrencies, crypto tokens, not only for bad guys, it can be used for good guys as well. We can use it for good things. For example, you can create a social network like Facebook, where people store the data and they pay for tokens, and then when the advertisers want to advertise, they have to purchase those tokens and then advertise, and then the value of token get appreciated, and then if you want some tokens by contributing your data, you can earn money. So then this kind of data monarchies like Facebook, like companies may disappear. So people have their own social networks. So with IPFX, that we are going to such directions. So as I mentioned, of course, crime is bad. So it not says that governments are good, right? So the bad guys take ransom, governments collect tax. So kind of similar, right? So then both are same. So then as a people, basically should decide and will decide in the future what might happen. So if the communities or the people stop using rupees, and if some person opens a supermarket which sells goods in Bitcoin, so then people may start using Bitcoins and then or other currencies. So then how do we going to control? I don't know what government might do, but people might start, I feel, there might be economies created for different purposes, and then in those economies there might be tokens, cryptocurrencies may be created, has their own values in those economies, and people may start using those tokens and will do their activities. Then dollars, rupees may not have values in this future world. So with that thought, I would like to end my presentation. So if you want to learn about how really it works, how to do programming, and there is a one-day workshop tomorrow, anybody can attend. Any questions if you have, I would like to take. And I have copied some slides from this course. So if you have time, you can have a look. Blockchain at Berkeley. So they have very good video sets and slides and examples, coding and so on. Have a look on this website. It's a postgraduate course on blockchain and smart contracts. I have taken some slides from there, so I would like to acknowledge. Any questions or anything you want to ask? How do they?
The currency generation is mostly related with digitized things, like say.
Yes, it's digitized. So for example, there are two ways of generating. One is mining. Yes. Other one is at the beginning they generate a fixed number of tokens, okay, like 100,000 notes, 100,000 coins. So that is fixed, and they release to the market. So and the other one is using some algorithm, they mine it. again there is a fixed number we can create it, or mine, or find.
So is there any other way to generate these, as you said, the work done by, the currency is based on the work done?
Currency is based on the work done, or maybe application value, or maybe something else.
Yeah.
Processing power, work done means processing power, maybe electricity, maybe a buying power, maybe anything we can relate to a currency, or token in other words in general. Bitcoin is kind of associated with the power.
So my question is, how long it will take this to come into the into a local setup, say, for example.
To the end users, you mean?
Yeah.
So people already use it, I guess, but I know some exchange point even in some Colombo places. People used to send the money to their kind of relatives, black money, so this, money laundering.
Okay.
People already start using it, end users. So if you have Bitcoin address, you go to this money exchange place, pay your Bitcoin to him. He will transfer your friend somewhere in other part of the world, and he can go to the exchange and make it to real currency. People start using it. Some stores already accepting, especially underworld stores, like there are different internet called darknet, which works on top of Tor hidden network. So all the drugs, whatever underworld payments now goes through cryptocurrencies. So that's why there is a huge demand for such currencies.
I have a small question. I think in my understanding in any economy, goods and services,
Yes.
if the goods and services goes up, then the amount of the currency circulate in that particular context depends on it. If there is no much good, no good services, you don't need much currencies.
Yes.
That's what we have seen in the history. People are not bothered so much of money because people just exchange directly the goods and services, and that's happened.
Yes.
I mean, there wasn't a time in the history where people didn't want to have any currency.
Yes.
Now, in today's context, what we have seen, the goods and services are going up. There are lots of transaction, what we say is happening. But now, what I understand in the cryptocurrency, if we have a particular block or something, maybe a number of coins, or it may be based on the mining as you explained, sometimes there isn't a limit for the currencies that could be generated.
In the cryptocurrencies, always the limit. Always the limit.
So then in the real society, the goods and services, the fluctuation, it's depend on the actual people's supply and demand,
yes.
in other words. But if the cryptocurrency cannot accommodate that requirement, then always there will be a kind of a bottleneck.
What's happened there is, since there is a finite supply, so the value always appreciate. So for example, if you own 1 Bitcoin today, you definitely know down the line it may up to $20,000, because it's a limited supply. If the demand is going up, so the token you own get appreciated. So example, if you create an app and then hold some set of tokens to you and release it, at the beginning maybe it may worth 1 rupee, 1 token. But if the people start exchanging those tokens and then demand gets up, and then there is a limited token in the market, then the value for 1 token will go up.
Yeah. So that means because it is not possible to increase now in the
Yes.
governments, what we have seen,
They are increasing.
they are increasing the amount of the money,
Yes.
the currencies. I
Yes.
mean, that's a kind of a solution. Whatever the authorities are something.
Yes.
So
in this economy, no such.
No such thing.
No
So there
such
isn't no people who are controlling.
Yes.
But sometimes what I feel, that may be badly affect the kind of people who can participate in the transaction.
Correct. Because if you want to buy bitcoins, maybe you have to pay more. So there is a solution in this system. So they actually usually in dollars it's a rupees, right? Sorry, dollars we have cents like 100% values. But in the cryptocurrencies you can divide into 1 million part of it. So it's you can buy not only one bitcoin instead of 0.0001 bitcoin, kind of like that.
Like a rupees and cents.
Rupees and cents. Then the rupees and cents, we only have rupees and cents. No, it's like only 2%, two decimals.
Yeah.
In the regular currencies. In the cryptocurrencies, usually support up to 18 decimal places. It's a small denomination.
So then, can we have a kind of smaller currencies where you one bitcoin you split it into?
No, instead of if you want to invest, maybe you invest on 0.11 bitcoin or something like that, or maybe other currency which has less values, and see whether what might happen. So Ethereum is kind of, people say, some good coin to invest, and other one nowadays people say Monero coin. So in even this blockchain, Bitcoin, even we say is anonymous, there are method of de-anonymizing. One of our MPhil student also doing that, and because of that, for the bad guys now moving out from the Bitcoin to another coin called Monero coin. So maybe you can invest and see what might happen on these new coins. Any question?
Actually, I have two questions.
Mm-hmm.
Basically, when we focus on the cryptocurrency on the financial perspective, so let's say if we define very brand new, fresh financial ecosystem through cryptocurrency, I mean, according to the session now, what I think is that the initial fund, that means let's say if I have created a financial ecosystem and there are two peers A and B there. A wants to transfer, let's say 5 whatever the units there, either Ether or Bitcoin or whatever. So if A wants to transfer 5 Bitcoin to B, how the initial, I mean, does it have how the initial set of money?
Initial money.
Yeah. Through the is it through the mining?
It's through the mining. So, for example, in the Bitcoin, the first block is called Genius block.
Yeah.
It has a transaction to himself.
Okay.
And he mines himself.
And he releases set of tokens to the ecosystem. Right?
So this is mining method. In the token method,
Yeah.
so if you create a token,
Yeah.
you create a smart contract with maybe 1 million token.
Okay.
And then you transfer from 1 million this token to people. Start transferring from that people.
Okay,
so that's a fixed supply.
Okay, it is for ICO, right?
That's for ICO.
ICO, okay, and another one that for the smart contracts, let's say smart contract is immutable kind of code, right?
Yes, storage.
Yeah, stored in the all of the network.
Yes.
So I just asked that can we include, let's say for fuzzy logic, a kind of fuzzy-based logic through the smart contract?
Actually, in the smart contracts consist of logics,
Yeah.
and logics and some small data storage.
Yeah.
So they don't have direct input outputs from the world, because contract need to be persistent at every machines when they executed. So if there is a function which take input from my computer, and the same function execute on your computer which take the different input, then different results, then contract may not work. So usually in the contract has a minimum interaction outside. So, but in the practically when you go out, we need to have external inputs. So for example, let's say we have a smart contract for supply chain management.
Exactly.
So then when some goods arrive to some points, that need to be informed to the contract,
Yeah.
saying it's arrived
Yeah.
securely.
Yeah.
So this I didn't talk about it. It's called, it has oracles, data oracles, and then sensor oracles and so on. So oracles means in this concept, it's actually trusted inputs. So those economies has to establish some trusted external inputs to the contracts.
Okay, so for let's say in the entire supply chain, let's say we have different set of tasks to be executed on different phases.
Yes.
So we will have a kind of global smart contract all over the network,
yes.
right? It
Yes.
should be immutable and it should be global, right?
It's a global.
Okay.
It's a global, and then the parties who participate in this contract need to agree with trusted entry points. That means oracles. So when those oracles enter some data, everybody in that network consider they are true and correct. And then function will execute it based on this.
Function will, let's say that if we have smart contract for logistics or even for the 3D printing scenario.
Yes.
So in this case, let's say if the design file for the 3D printing scenario, I think you know it. For in this 3D printing scenario, if the design file has been received by the 3D printing entity, we should execute the printing, right?
Yes.
So if to do that, this condition should be definitely distributed in all the other peers of the network.
Yes.
The smart contract, right?
Yes, yes.
That's the way.
The contract will execute everybody.
So if let's say if we if due to some due to some kind of business requirement, if we need to alter the logic,
you can't. In the smart contract, if you write a code, if that code has a bug, maybe all of your tokens has gone. Some hacker may stole.
Exactly.
That might happen to this the decentralized organization, the DAO. So kind of billions tokens has stolen from the contract because it had a bug. So you have to perfectly test. You have to deploy correct codes, not the untested codes, because no way to alter the code.
That means due to whatever, let's say that due to business requirement or whatever, we cannot.
No. That contract is fixed. Then you have to upgrade it. You have to introduce a new contract and then transfer money from old contract to the new contract. So right in the old contract, you should have some function there which allow that. Otherwise, that may not be able to possible as well. So these things carefully need to design, test, and deploy. Any questions or? Okay, if you have any questions, you can take offline as well as you can take tomorrow, right? Okay, thank you. Thank you very much.
Thank you, sir. Now I would like to invite Professor N.D. Kodikara on stage to present the token of appreciation to Dr. Kasun de Zoysa.